It was a very exciting day for the Bloodhound team last week as Rolls-Royce announced their official support for the programme. Their amazing engines have been in record-breaking cars, boats and planes for over 80 years. It's great to be able to add that famous name to the car. They were particularly attracted by the Bloodhound education programme and are providing 56 ambassadors. These will visit schools all over the country, helping teachers with Bloodhound-themed science lessons and also giving an insight into the interesting careers available in engineering.
From a personal point of view, I find it hugely exciting. From a professional point of view, I think this is really, really important. The amount of schools, I think it's 5,500 schools you've now got engaged over the internet and other mediums. It's just, I can't think of another engineering project that has that level of engagement. And sadly, in my view, in the UK, there aren't many big engineering projects that have even tried to get people involved such as that. Well, Rolls-Royce is a global company. Many of our customers, the majority of our customers are overseas in far-flung parts of the world. The educational system in those parts of the world are much more coherent in terms of how they educate science and technology apprentices and graduates. And one notices that the UK is being left behind. I'm not sure it's easy for a 10-year-old to understand, but it's exciting for a 10-year-old to understand it. You can see the project real time being built and being engineered. I think it's a massive scale of undertaking, but it needs professionalism, it needs challenge, and it needs dedication to do it, and that's what I think the Bloodhound team bring.
Rolls-Royce is actually very committed. On the graduate scheme, all of us are encouraged to take part in and sign up with different community projects and education projects. Bloodhound is such an exciting project for schools. All the kids we've worked with today and in schools in the past have known what it is. 1,000 miles an hour, it's something they can really get behind and go, wow, we're doing that, we could do that when we grow up. It's a really inspiring project. It's great. Unfortunately, it is true, there's still a massive shortage of women in engineering. Even here at a great company, it's a very small percentage. I think the key is education and saying, it's not just the boys, you can do this. It's no easier for them than it is for you, or it's no harder for you than it is for them. Just giving them the confidence to get involved, put their hand up and say, yeah, I can do that.
Rolls-Royce built the EJ200 and also helped to design a custom air intake to help it function correctly in Bloodhound's extreme environment. The jet engine will be the first thing that gets Bloodhound moving. It has an amazing power-to-weight ratio, weighing less than a tonne and putting out 20,000 pounds of thrust, enough to get the car to 650 miles an hour without the aid of the rocket. It's one of the most advanced engines in the world and even has its own brain on board to help it operate safely. One of the main challenges in using this engine for the car has been to design a system which can communicate with the engine and tell it that it's fine to be doing 1,000 miles an hour 1 metre off the ground.
This box here, this is the box that was tested or used to test the EJ down at Rolls-Royce. Obviously it's just a plastic box. We'll have to repackage this. Some of these buttons will represent maybe a foot pedal or a lever in the cockpit. We'd previously tested this unit and the code with their jet engine simulator. So it was deemed that the next step to prove the system was to do a real run. We just went through testing a jet start and then testing or doing a simulated hack scheme pan run.